What exactly is the center of the Milky Way? Why does the brightness increase as we get closer to the center of the Milky Way? As we all know, the Milky Way is a huge disk with a diameter of over 100,000 light-years. Currently, Earth is located above the Orion spiral arm. From our position, the grayish-white band in the night sky is formed by the vast spiral structure that makes up the Milky Way, and it has undergone a long period of development. It is widely believed that the solar system centered around Earth constitutes the entirety of the universe, and few people pay attention to the nature of those distant stars. It was not until the 17th century that the famous astronomer Galileo Galilei discovered a band of light composed of numerous stars using a homemade telescope. By the beginning of the 20th century, astronomer Harlow Shapley proposed that billions of stars, including the Sun, collectively form a flat disk-shaped Milky Way galaxy, with the Sun located at the edge rather than the center of the galaxy. With the advancement of modern astronomical observation technology, humans have learned that the Milky Way is a barred spiral galaxy composed of at least 100 billion stars, consisting of a central bulge region and several spiral arms extending outward. Earth is located on the Orion arm, about 26,000 light-years from the center of the Milky Way. So, how far is this distance? Currently, the Voyager 1 probe, which is the farthest from Earth, would take at least over 400 million years to reach the center of the Milky Way, even if it travels at the third cosmic velocity. The most mysterious part of the Milky Way lies in its core region. Scientists, after conducting observations using X-ray and infrared telescopes capable of penetrating the obscuration of interstellar dust, have discovered that the center of the Milky Way is actually the region with the highest density of stars. The closer you get to the center, the greater the density becomes. This area is home to over 10 billion stars, whose brightness is unimaginable. In such a region, thousands of dazzling stars are scattered in all directions, and the intense light they emit would permanently blind you. Most of the stars in this region are ancient stars, some of which are red giants, with brightnesses thousands of times that of the Sun, and most of them are over 10 billion years old, far exceeding our Sun, which is about 4.6 billion years old. You may wonder why these stars are concentrated in the center of the Milky Way. Based on theoretical predictions, British astrophysicist Donald Lyndon Bell posited that the center of all galaxies, including our Milky Way, harbors a supermassive black hole. According to Newton's law of universal gravitation, the greater the mass of an object, the stronger its gravitational pull. A supermassive black hole, as the term goes, possesses a mass thousands or even tens of thousands of times greater than that of an ordinary black hole. The closer one gets to such a black hole, the stronger the gravitational force becomes. Consequently, numerous stars are gravitationally bound and possibly confined by dark matter, rendering the center of the Milky Way exceptionally bright. Almost every galaxy harbors a supermassive black hole at its center. In May 2022, the World Telescope Collaboration captured the first ever image of the black hole at the center of our Milky Way galaxy, undoubtedly confirming this assertion. The image reveals the colossal black hole at the heart of our galaxy, known as Sagittarius A. It serves as a reminder that the universe is far more astonishing than we could ever have imagined. Although humanity is currently unable to venture beyond our Milky Way, when we gaze upon the grayish-white Milky Way, we are essentially looking up at our own galaxy and, by extension, our universe. The solar system resembles a vast cage, prompting one to ponder. Will humanity forever be confined within this system? Imagine if the entire solar system were scaled down to the size of a city. The Sun would be positioned in the center of the city square, its volume reduced to the size of a marble. Earth would hover about 1 meter away from the Sun, its reduced volume almost imperceptible. Neptune would be situated about 30 meters from the edge of the square, its size comparable to a grain of fine salt. This central square encompasses the entire range of motion for the Sun and the 8 planets, yet this is far from the limits of the solar system. Leaving the square, we continued on our journey, passing through the urban area and reaching the suburbs. After traveling for dozens of kilometers, we arrived at the outermost edge of the city. Here, there is a cloud-like sphere composed of countless icy celestial bodies, quietly surrounding the entire city. This is the famous Oort Cloud, a structure proposed by the Dutch astronomer Jan Oort. These icy celestial bodies resemble a giant bubble, completely enveloping the entire solar system, with a radius exceeding 1 light-year, which is also the true boundary of the solar system. As we all know, 1 light-year is the distance that light travels in 1 year, and the speed of light is millions of times faster than the speed of an airplane. This means that even if we travel at the speed of an airplane, it would take 1.2 million years to leave the Oort Cloud. At this point, humans realized that the solar system we are familiar with is far more complex than just the 8 planets. In fact, the gravitational influence of the Sun extends far beyond 2 light-years, binding countless celestial bodies within the solar system and collectively forming an invisible boundary structure, akin to a vast cosmic cage that spans the universe, and we are situated within it. From this perspective, is it possible for us humans to venture beyond this range? The answer seems rather pessimistic. The interstellar travel depicted in many science fiction movies is ultimately a fantasy. According to Einstein's theory of relativity, no object with mass can reach the speed of light, and even approaching it is beyond the exploration range of current human spacecraft. Currently, human exploration remains confined to the immediate vicinity of Earth, and all we can do is establish space stations near Earth's orbit for limited and transient research and work. Despite tremendous efforts, humans have only successfully landed on the Moon once through the Apollo moon landing program. Even if a manned starship is developed in the future, the fuel problem will still be an insurmountable obstacle. In the vast expanse of the universe, it is difficult to find usable fuel, let alone the even more enormous Milky Way beyond our solar system. And the observable universe above the Milky Way contains 2 trillion different galaxies. In the boundless universe, even if humans can leave our solar system, we would merely be marking time, as we still face greater unknown challenges. For example, what would happen if we accidentally strayed into Jupiter? As the largest planet in our solar system, Jupiter's volume is more than 1,300 times that of Earth, which is like a speck of dust in comparison. Once you approach Jupiter, you will be captured by its powerful gravity from tens of thousands of kilometers away, and your field of vision will be completely dominated by Jupiter. With endless expanses in all directions, Jupiter is mainly composed of gases such as hydrogen and helium, so you will see many huge stripes and vortices. These crisscrossing flowing stripes are actually high-speed flowing gases. You will fall toward Jupiter at a speed of about 50 kilometers per second, and the weightlessness brought by this speed is extremely intense, even more thrilling than roller coasters and large pendulums. In this situation, any human protective clothing would be washed away and shattered by Jupiter's powerful airflow. Therefore, we need to wear specially made super protective clothing to prevent danger during the rapid descent. As you continue to descend, you will find yourself approaching Jupiter's Great Red Spot, which resembles a swirling vortex. It resembles a giant eye, fixedly gazing at you. The Great Red Spot is Jupiter's most iconic giant storm, with its diameter reaching up to 40,000 kilometers at its longest in history, large enough to accommodate 3 Earths. You will plunge deep into the giant vortex and descend into an endless abyss. The wind speed of the Great Red Spot can reach up to 500 kilometers per second. This storm has been raging for at least 300 years and is the largest storm cyclone in the solar system. The closer you get to Jupiter, the more you will be enveloped by a sea of rapidly rotating clouds, with thick gases surrounding you from all directions, accompanied by lightning flashes. This will be a truly spectacular scene. As you delve into the heart of the Great Red Spot vortex and continue to descend into the middle layer, you will see nothing. Not even light can penetrate, only endless darkness. Since everything below this layer is in the realm of darkness without light, the naked eye cannot observe anything. But thanks to scientific instruments, we can understand its internal structure. This layer is primarily composed of high-pressure gas, with temperatures that can reach tens of thousands of degrees Celsius. Any substance here, will instantly turn to dust. Fortunately, with the protection of super protective suits, we can continue to delve deeper and eventually reach the deep sea composed of liquid metals. Here, any structured objects cannot exist and will be decomposed into a flowing and viscous ocean of atoms due to the extreme pressure. The super high pressure causes these liquids to flow extremely slowly. This is the deep region of Jupiter. Once you enter, you cannot return and have become a part of Jupiter. As we all know, a light year is an extremely large unit of length, referring to the distance that light travels in a vacuum in 1 year, approximately 9.46 trillion kilometers. In comparison, the diameter of the Earth is only about 12,700 kilometers. This means that the scale of 1 light year is equivalent to the length of over 700 million Earths connected end to end. If we build a highway with a length of 1 light year, that is 9.46 trillion kilometers long, how long would it take for humans to travel this distance at their current fastest speed? Firstly, the walking speed of humans is about 5 kilometers per hour. At this speed, it would take at least 200 million years to travel 1 light year, which is far beyond the lifespan of humans. Even if we drive a car at a speed of 100 kilometers per hour, it would take 10 million years to complete this journey. For commercial airliners, although they can travel between multiple countries around the world in a few hours or days, it would take millions of years to fly 1 light year. Finally, taking the Saturn V rocket as an example, it is the largest carrier rocket ever launched in human history, with a top speed of about 40,000 kilometers per hour. However, even so, it would take 27,000 years to complete a 1 light-year journey with it. The fastest man-made machine, the Voyager probe, travels at an astonishing speed of 17 kilometers per second, which means it takes only a few seconds to travel between 2 cities. However, to complete a journey of 1 light year, Voyager still needs 17,600 years, which is still extremely slow on a cosmic scale. Therefore, measuring humans' visual range in light years seems extremely distant. But do you know? Most of the stars you see in the night sky are tens, hundreds, thousands, or even tens of thousands of light years away from Earth. Even our nearest neighbor to the Sun, Proxima Centauri, is 4.2 light years away from Earth. All the light emitted by stars has traveled for years, or even thousands of years, at the speed of light of 300,000 kilometers per second before reaching Earth. And for the Andromeda Galaxy, which is located outside our Milky Way, its light has traveled for over 2.5 million years before reaching Earth and being seen by us. This is just the nearest large extragalactic galaxy to us, showing how vast the visible universe is. Even if humans could travel at the speed of light, what would that achieve? If humans could truly pilot a light-speed spacecraft from one end of the Milky Way to the other, it would still take hundreds of thousands of years. Clearly, the speed of light remains an extremely low velocity in the context of the universe. Humans cannot even reach 1,000th of the speed of light, so they cannot even traverse 1 light year. Could Earth be a single cell in the universe? In the vast expanse of the universe, where exactly is Earth located? As we all know, Earth resides in the Milky Way, which contains over 200 billion stars. Finding Earth in such a galaxy is akin to searching for a needle in a haystack. In 1951, American astronomer William Morgan and his team observed our Sun for the first time through an optical telescope and discovered that it was located on the inner side of the Orion spiral arm of the Milky Way. The Sun has 8 planets, with Earth being the 3rd one. The region where the 4 inner planets are located is called the inner solar system, while the region where the 4 outer planets are located is called the outer solar system. However, the solar system is not special in the universe. Almost every bright spot in the Milky Way is like the Sun, surrounded by numerous planets. The Sun is just a tiny existence among many bright spots. For a long time, it was widely believed that the Milky Way was the entirety of the universe, including Albert Einstein, who held this view at that time. But later, the famous astronomer Edwin Hubble observed the Andromeda Nebula using the world's largest telescope at that time, the Hooker telescope, and discovered that it was actually an independent galaxy. From then on, people realize that there are countless other galaxies in the universe. Although the Milky Way appears vast to us, it is actually just one among many ordinary galaxies. When we look further, the Milky Way is located within the local group, which consists of the Milky Way, the Andromeda Galaxy, and approximately 50 dwarf galaxies, resembling a small town made up of dozens of villages. However, the local group is part of a larger astronomical system, the Virgo supercluster, composed of dozens of such towns. In this level of astronomical system, the light of the Milky Way no longer belongs to itself, but rather becomes a giant galaxy, covering an area of over 100 million light-years. But even so, above the Virgo supercluster lies the even larger Laniakea supercluster, resembling a large city containing approximately 100,000 galaxies, of which the Milky Way is just one. What is even more incredible is that Laniakea is merely a drop in the ocean of the universe, as above it lies a vast network of countless galaxies. These supercosmic webs, each composed of individual galaxies, collectively constitute the entire observable universe, with a diameter reaching an astonishing 93 billion light-years, which is the limit distance observable by current human technology. Besides, our understanding of the universe is still superficial, but we already know the specific location to travel to Earth. We need to start from the observable universe, search for Laniakea, then proceed to the Virgo cluster, and subsequently find the local group and the Milky Way where humans reside. From the Orion Arm, we can locate the solar system and ultimately find Earth. In the grand scheme of the universe, Earth is like a speck of dust, and everything we have, including our achievements, faults, fame, and wealth, all occur on this speck of dust. Where are the aliens? Given the vastness of the universe, why have humans not encountered aliens yet? Don't blink, this video will teach you how to search for aliens. Firstly, anyone who has counted stars as a child knows that over 99% of the twinkling lights in the night sky are stars. Stars emit light through nuclear fusion, and the sun is one of them. However, due to the high temperature of stars, which can reach up to 5,500 degrees Celsius, no living organisms can survive. Therefore, searching for aliens must start with planets, especially those terrestrial planets with rocky surfaces orbiting stars similar to the Sunday. At the same time, these planets need to be located in the habitable zone, at a distance that is neither too hot nor too cold, to ensure that water can flow in liquid form and form a comfortable climate. In short, we are searching for terrestrial planets suitable for life. For example, this is a photo of Mercury taken by the Messenger spacecraft. Due to its proximity to the Sun, Mercury is directly exposed to sunlight during the day, and its temperature can reach up to 427 degrees Celsius, resembling a burnt apple. And this is a photo of Uranus taken by the Webb Space Telescope. Due to its distance from the Sun, Uranus is extremely cold, so much so that it is classified as an ice giant, much like a frozen planet. Clearly, in the solar system, only Earth meets these criteria and is unique. Therefore, our method of searching for aliens seems to leave us with only one option. In March 2009, the Kepler Space Telescope was launched. This space telescope, developed by NASA, is primarily used to search for other planets. However, even the most sensitive telescopes can only capture the faint light of stars in the night sky, let alone capture planets orbiting around them. So, how do we detect habitable planets? When a planet passes in front of a star, it blocks some of the star's light, causing a slight decrease in the star's brightness. Even if the brightness dimming is only 1/10,000th, the highly sensitive Kepler telescope can detect it. This is known as the transit method. By observing this brightness change, scientists can determine the existence of planets and further calculate their orbits and other data. For example, Kepler 22b is the first exoplanet discovered by the Kepler telescope that is located in the habitable zone and orbits around a sun-like star. It is 2.4 times the size of Earth and is known as a super-Earth, despite being 600 light-years away from us. Water is the source of life, and all animals and plants on Earth rely on water. It can be imagined that if we cannot find life where there is water, it is even less likely for life to exist where there is no water. In 2015, joint observations by the Kepler and Hubble space telescopes discovered evidence of water vapor in the atmosphere of the habitable zone planet K28b, indicating the potential existence of liquid oceans on the planet. However, due to K28b's distance of 124 light-years from Earth, the presence or absence of extraterrestrial life remains a mystery. From 2013 to 2018, the Kepler telescope discovered a total of at least 2,500 planets. Based on these data, scientists estimate that there may be 20 billion inner planets in the Milky Way, but they are all extremely distant from our solar system. Although every star in the night sky could potentially host extraterrestrial life, the closest planet to Earth where an alien civilization might exist is 4.2 light-years away. With current technology, it takes about 17,000 years for a spacecraft to travel 1 light-year, and it would take 10 million years to reach Kepler 2b, which is 600 light-years away. Therefore, the reason why humans have not yet discovered extraterrestrial life lies in the vastness of the universe. Even if a planet with an alien civilization is discovered outside our solar system, we are still unable to explore it physically. So far, no response has been received to the signals sent into space by humans. Will aliens come to Earth? In fact, our solar system, our galaxy, is not located at the center of the Milky Way, and the surrounding stars are sparse, making it difficult for Earth to be discovered by extraterrestrial civilizations. Even if an advanced civilization discovers Earth, they may not specifically come here, preferring to search for higher civilizations in the Milky Way, where resources are more abundant. The universe is indeed vast, and we may never be able to leave the Milky Way or find similar extraterrestrial species. However, in this vast universe, humans are not alone. We just haven't found them yet. Our Sun is located in the Orion spiral arm, and together with at least 200 billion stars, it forms this vast and beautiful galaxy. Whenever we look up at the milky band of light on a clear summer night, that is what we call the Milky Way, which is also a part of the Milky Way galaxy. Almost every spiral arm of the Milky Way is composed of countless stars, all revolving around the center of the Milky Way together. Our Sun, along with its 8 planets, takes about 250 million years to complete such a revolution, a period known as a galactic year. Apart from the spectacular cantilever, the most striking part is undoubtedly the exceptionally bright region in the central area of the Milky Way, which we refer to as the galactic center, with a diameter of about 20,000 light-years. So, why is this region so exceptionally bright? Please follow me to explore the central region of the Milky Way and reveal this mysterious phenomenon. As we approach the galactic center, we will find that ancient stars billions of years old and red giants thousands to millions of times brighter than the Sun are almost everywhere. The density of stars in the center of the Milky Way is so high that it is difficult for us to imagine. Even looking directly at the Sun with our naked eyes can cause some damage to our eyes. But here, stars are densely packed in all directions, some of which are even red giants with astonishing brightness. This means that if we live nearby, reading by starlight at night would not be a problem. Therefore, the reason why the center of the Milky Way is so bright is precisely because of the dense distribution of these star families. Scientists have also discovered a supermassive black hole at the center of the Milky Way, located approximately 26,000 light-years from Earth. Known as Sagittarius A, it has a mass about 4.3 million times that of the Sunday. In May 2022, the first image of Sagittarius A times was released through the World Telescope collaboration. It plays a pivotal role in the Milky Way, forming a barred spiral galaxy with a diameter of about 100,000 light-years, along with hundreds of billions of stars, which we commonly refer to as the Milky Way. And we humans live in a corner of such a galaxy, on a planet Earth orbiting a yellow dwarf star. However, compared to the entire universe, the fame and wealth we pursue in our lifetime may be insignificant, as we are truly insignificant. Therefore, when we feel sad or upset, looking up at this bright, starry sky may bring us some comfort.